So this is cloud computing, a weapon of mass destruction. If this isn't the right talk for you, the door's that way. I'm David BRYAN, technology enthusiast, hacker extraordinaire, security consultant. I also help run the network at DEFCON and do all sorts of fun things with OWASP and DEFCON groups and whatnot. How many people here are part of a DEFCON group? Yes? No? You should start one in your city. It's fun. Get together and meet and talk about things like this on a regular basis.
Hi, I'm Mike Anderson, and if the lack of information in my bio hasn't clued you off, I'm new. This is my first DEFCON, and I've been at a company called NetSpy for just a year now. This is my company, NetSpy. We do a whole bunch of different stuff, but we kind of got to keep this presentation pretty short, so I'm going to breeze through it. We do all sorts of vulnerability assessment, pen testing, code reviews. Next slide.
All right. Does everybody know what the cloud is? Custom server images, central storage, all sorts of fun things. No physical systems to worry about. Have anybody had problems with power in their data center? Has anybody had problems with cooling in their data center? I think we all have. This is kind of a nice environment because you don't have to worry about that. In fact, you don't have to pay minions to manage it. You just deploy machines. It has custom APIs, which you can then go in and manage your storage, manage your machines, deploy new machines, ramp up machines as your load increases, that kind of thing. Storage. It also has a queuing system where you can send a shitload of messages into it and it'll parse them out and send them to you in nice, pretty timing format and all that fun stuff. There's more seats up in front here, by the way. There's like 5 seats up in the front here and there's like 10 seats over here. So keep coming up.
We're going to start a brawl, man.
All right, so what can I do in the cloud? Obviously scale and deploy large environments. Can it get rain? Maybe. It's a cloud, right?
That's what we're here to talk about.
You can move your servers very quickly from the UK to Singapore or east and west across Americas. You can have large amounts of bandwidth just at your hand or at your whim. It's kind of nice. All right, so what's required?
All you need to start an account with Amazon EC2, which is the environment we did our tests on, is an email address, a credit card, and you need to look at an API. There's no contact information. There's no contract. They don't try and figure out who you actually are. It's just sign up and you're good to go.
Yeah, I mean, there is a terms of service that you have to hit accept on. Click, right? There's no signing. There's no nothing.
There's a EULA.
Yeah, EULA, basically. Everybody knows that EULAs are rock solid, right? All right, so our question is it a useful tool or a weapon of mass destruction? So in the cloud computing weapon of mass destruction, basically this is what we're going to talk about, sort of an outline, threat agents, attack types, defenses, and we'll also do a demo if we can try and get the presentation in before the end of the hour here. So some of the threat agents.
So a threat agent can be anyone from a business rival, organized crime, or foreign powers, like a pirate maybe, as the picture would indicate. And what they're basically in this for is maybe bragging rights or money and power even. It's become a serious topic. It's no longer just a game. And here's an example of a threat agent attacking for money or power, Google China. They got owned for political reasons, actually. So some of the key terms that we're going to talk about in this talk is DDoS, Distributed Denial of Service Attack. How many people have heard of that? All right, good. Good. Fragmentation attacks, yes, a few less. And our tool doesn't specifically focus on fragmentation attacks. It's mainly on SYN floods and TCP denial of service type attacks. And SYN flood, does everybody know what TCP is? TCP IP? Everybody should raise their hands. All right, does everybody know what a command and control is? So in a typical botnet, you've got a command and control network with a herder. The herder is, a threat agent, a person who's actually saying to these bots or zombies, do this.
It takes a long time to gather these machines. I mean, you're talking months and months of painstaking rooting or exploiting Windows-based machines, trying to get them across. And you're also having to worry about, is antivirus enabled? Will it catch my stuff? Will I, have maybe some sort of a 56K leased line, or is it a modem connection that I've now basically taken over a computer that has no bandwidth? Well, that's no good to me as a herder.
And what's more, once you've established a botnet, you still have to pay maintenance costs. You have to keep ahead of the antivirus researchers. You have to update it. You have to keep track of all kinds of different things, which can take a lot of time.
And most systems are Windows. So just sort of a diagram of what a typical command and control would look like, where you've got a herder in one corner, and then you've got the machines that are actually attacking the victim. So our concept we call ThunderClap. I don't know why we came up with this. I think, thinking of the cloud and all that fun stuff. But anyway, basically it's a proof of concept. We run a DDoS attack from the cloud. We've written some modules that aren't quite fully flushed out to use social media as a herder for them. But basically the cloud environment allows you to do rapid deployment of these systems. You can say, all right, let's deploy 10 systems, and boom, they're up and running. There is some restrictions within the Amazon environment for how many machines you can deploy at a time. However, there's no restrictions for you to be able to go out and use more credit cards to deploy more environments. So, and email addresses, those are really hard to come by. All right, so
in our environment, the herder, the command and control network, is actually in the cloud with the botnet. So there's plentiful bandwidth there, and that can be guided anonymously through social media or Tor, and it can be really hard to track, because if you have these instances in EC2, for example, when you shut them down, none of your data is persistent, especially logs. So nobody can come in and check what you were doing. It's totally gone when you're done.
All right, so same diagram, except now think of it as all being in the cloud rather than having devices that are dispersed throughout the internet, essentially. Makes it a little easier to track, maybe a little easier to shut down, but, we'll talk about that later. All right, so attack types: TCP full connection, packet fragmentation. Again, we didn't implement this in the proof of concept. And then TCP SYN flood. These are really basic attack types. The full connection would use a lot more resources on our end, so we try not to use that as much, because we're going to have to actually open up the socket, reserve some memory for the receiving connection to come back so we can get a SYN, SYN-ACK, that kind of thing. TCP flood, SYN flood, is a little bit more dangerous and a lot more bandwidth intensive, because all we're doing is sending SYNs and we're not waiting for an ACK. We're just going along.
So using this sort of attack, we can target a website, server, service. Doesn't really matter what it is, and it doesn't matter how many of them there are. We can target something that's been dispersed. We can target a centralized resource, and we can make money off of it. We can basically say, we're going to denial of service you for an hour today unless you pay us $5,000. And if you don't pay us, it'll be 2 hours tomorrow. And if that doesn't work, we can try and sell this service to competing companies. Like, we can come to Target and say, hey, do you want us to shut down Walmart for 6 hours right after the release of the new PlayStation? Because we'll do that, and you only have to pay us $5,000. And you can make tons of money this way, probably. We haven't tested it.
Maybe today we will. Anyway, so ensure your website is down for good. Again, blackmailing, doing all sorts of low-life things. So the outcome is threat agents can hold your environment hostage quite easily, cheaply, and who's watching again? Now, when I say cheaply, guess how much it cost for us to run a 2-hour test against a site that was 6 gigabits of traffic? $6. It was $6 for us to kill a website for 2 hours. That's pretty cheap. I think it cost us $30 for the machine time to get everything prepped and make sure it was up and running. Once that's up and established, it probably would have cost us all of about $12 to run that whole attack. And we could potentially continue to run that day over day over day. And who's watching again? No one contacted us. Is there anybody from Amazon here? They're not going to raise their hands. Damn. We found that we generated a lot of anomalous traffic and anomalous type situations in the cloud, and no one called us and said, hey, what are you guys doing? We didn't even get an email, which is how you're supposed to communicate with them, which is a little frustrating, but. All right, so ThunderClap.
So this is the tool that we built to run this test. And more or less all you had to do to make an environment is get the credit card, sign up, and you have to make a machine image, which can take a little while. You just have to make sure that your tool is persistent across reboots. And then you can just deploy zombies. There's a little drop down. You can say, I want to deploy 10, 20 contract, or click yes, I agree again. But it wasn't a huge obstacle for us. We had to create the tools, and in the development process, I kind of went through a couple of iterations using Scapy, HPing, and libdnet. I settled on the last two because Scapy didn't offer me the same amount of control over setting up and destroying sockets. And you have to develop attacks, and this is actually pretty easy because it doesn't take much to do a TCP full or a SYN no data attack. It's just kind of fiddling with it to get the most bang for your buck. That takes some time.
And we did, we developed a randomized source IP with libdnet as well. However, attacking from the cloud, everything's natted, and so as soon as we tried to go outbound, it would drop it because it wasn't a natted wasn't a source natted traffic that it would allow out. But you could potentially attack inside the cloud, you know, and it's untraceable at that point. I don't know, this 12 address is coming from our networks. How does that work? So, all right, so we're going to try and do a demo. Hopefully the demo gods will be with us. Basically, the site that we're going to try and attack today is media.defcon.org, which I'm told has a 100 meg pipe. All right, so we should be able to just say, images. By the way, does anybody see this? No, they don't. All right. Let me give you a window here. Oh boy, I have to shrink this some more, I think. Stand by. All right, so unless, of course, someone's already done it for us. Oh, wait. No, I'm just kidding. All right, so we should be able to hit this. And basically, we've pre-configured our environment with the script. The tool is on the CD. But all I should have to do is say, whoop, launch this image. Power on. I can launch min servers, max servers. I'm going to say, let's go for 8. So we'll launch 8 servers. Hit launch. I should be able to go to instances. Hasn't anybody seen the Katy Perry video, California Girls, right? So Minnesota Girls. You should go check it out.
It's our soundtrack.
It's our soundtrack. We'll play it later. All right, so these guys are starting now. Let's see if they've come up. Come on, refresh. Takes a little bit. But so essentially what's happening now is these machines are booting up. They go out, they pull the script off of our S3 environment, which the S3, or the CloudFront environment, it's a storage environment, pulls the script down, starts it up, and then starts a Python attack thread. And goes and grabs the targets, goes and grabs the DDoS config off of that environment, and boom, it just starts spewing packets. I don't know what's going on with my network connection here. Let's see. I think they might have. Or our internet connection is goofy.
Is that 100 megabit pipe shared with us?
Oh, there we go. So now we got 2 running. So these machines are starting up, sending 10,000 packets per second. Every 5 seconds, they will send that traffic and go and check the targets file and go, all right, do I have more targets to process? Do I have more targets to process?
Did we get the, I don't know if we've done this yet, but we're going to put these images and the tool up on SourceForge and allow you guys to basically run the scheme yourself.
Yeah, there's a zip file on the CD.